Bosch electronic engines and sensors, the differential locks on the front and rear axles are targeted. That leads to greater vehicle stability and more neutral driving behavior. Only when the vehicle reaches the controllable limit does the ESP intervene, reducing the engine torque and applying brake pressure to individual wheels. Sometimes, though, even the transmission control is unable to adapt to the demands of the driver. Luckily, in such cases, there are other things you can rely on. The advancements of Bosch gasoline systems relating to all aspects of the drivetrain help to bring power to the road in the best possible way. That's yet another contribution we make to more driving comfort, more driving dynamics, and lower fuel consumption.
Bosch, invented for life.
Urban driving situations often involve a lot of stop-and-go traffic and waiting at traffic lights. Meanwhile, the engine is still running, using up fuel and producing emissions. And this is precisely where the start-stop system comes in. Here's a typical traffic light situation. The driver releases the accelerator and brakes, the vehicle comes to a halt, and the driver puts it into neutral. The system checks whether the engine is idle and no gear is engaged. The wheel speed sensor in the anti-blocking system is showing 0. And the electronic battery sensor is signaling enough power for the next start. Now the engine is automatically stopped. As soon as the light turns green and the driver presses the clutch, the start-stop starter receives the signal to start the engine. And the engine starts quickly and reliably. When the driver engages the gear and presses the accelerator, the vehicle can move off perfectly reliably and without delay. The start-stop system helps to save fuel and to lower CO2 output. It also gives you a quick, reliable start every time. Safe and reliable over the entire lifetime of the vehicle.
Bosch, invented for life.
Urban driving situations often involve a lot of stop-and-go traffic and waiting at traffic lights. Meanwhile, the engine is still running, using up fuel and producing emissions. And this is precisely where the start-stop system comes in. Here's a typical traffic light situation. The driver releases the accelerator, applies the brake pedal, and the vehicle comes to a halt. The system checks whether the brake pedal is depressed. The wheel speed sensor in the anti-blocking system is showing 0. And the electronic battery sensor is signaling enough power for the next start. Now the engine is automatically stopped. As soon as the light turns green and the driver releases the brake pedal, the start-stop starter motor gets the signal to start the engine. And the engine starts quickly and reliably. When the driver presses the accelerator, the vehicle can move away without delay and perfectly reliably. The start-stop system helps to save fuel and to lower CO2 output. It also gives you a quick, reliable start every time. Safe and reliable over the entire lifetime of the vehicle.
Bosch, invented for life.
Engines with gasoline direct fuel injection produce the air-fuel mixture in the combustion chamber. Fresh air flows with the induction stroke through the open intake valve into the combustion chamber. High-pressure injection valves inject the fuel directly into the combustion chamber. The cylinder charge is formed according to the driving situation. With a homogeneous charge, the entire combustion chamber is steadily filled with the air-fuel mixture on the induction stroke. This operation mode results in the highest performance when driving with a full load. Alternatively, a stratified charge is produced during the compression cycle. The combustible mixture cloud forms only in the area around the spark plug.
Bosch, invented for life.
The engine sucks in the fresh air through the intake manifold. The fuel is injected into the fresh air stream where it mixes with the air. In the induction stroke, the air-fuel mixture streams through the open intake valve into the combustion chamber. Engine performance is adapted to the required level by the electronically controlled throttle device. The electronically controlled throttle valve is opened wide enough to achieve the cylinder charge necessary to produce the required torque. Motronic electronic engine management delivers the torque the driver desires. The higher the engine speed, the faster all phases of each injection must be measured, calculated, controlled, and executed. Always adjusted to suit the current operational state.
Bosch, invented for life.
Consumers in all markets have similar requirements for new diesel passenger cars. They want vehicles that combine low fuel consumption and low emissions with powerful engine performance. Common rail systems from Bosch help to meet these requirements. The Common Rail System CRS-114UP was developed especially for the Indian market for low-priced 1 to 3 cylinder diesel engines in passenger cars and light-duty applications. Because all components are manufactured locally in India, the system can be offered at an affordable price. The CRS-114UP is ideally suited to replace the mechanical injection systems used up until now. The modular construction of the CRS-114UP system enables developers to adapt it to specific engine requirements at the lowest possible cost. High pressure is created with the plug-in pump PF51, which is driven by the camshaft and can deliver system pressures of up to 1,450 bar. In 1 and 2 cylinder engines, the fuel is delivered directly via a distribution block with an integrated rail pressure sensor, the RPS block. That lowers system costs. Single actuator operation is used in this system. The deployment of a fuel metering unit instead of a pressure valve results in a hydraulically efficient, controlled fuel delivery system. The resulting reduction in fuel consumption also means lower operating costs. In 3-cylinder engines, the fuel is distributed via high-pressure rail to the injectors. The solenoid valve injectors CRI-114 are supplied with fuel either via the high-pressure rail or the distribution block. The solenoid valve injectors can generate up to 3 individual injections per cycle. This reduces operating noise, makes fuel combustion more efficient, and reduces emissions. The Electronic Control Unit EDC-17 contributes to high-precision fuel injection and can be installed in the chassis in close proximity to the engine. The EDC also supports the operation of a lambda sensor. The EDC-17 enables adherence to current emission standards, such as BS4 in India, with improved engine performance at the same time. The Common Rail System CRS-114UP is another contribution from Bosch to making diesel passenger cars economical, clean running, and powerful. Bosch engineers are already at work on the evolutionary further development of the system so that it will conform to India's future emission standards as well.
Bosch, invented for life.
In all markets worldwide, three characteristics in particular are in strong demand when it comes to passenger vehicles: low fuel consumption, lowest possible pollutant emissions, with high-performance drive power at the same time. Common rail systems from Bosch help to fulfill these requirements. The Common Rail System CRS-116 was developed especially for the Chinese market for low-priced passenger cars and light-duty utility vehicles. Typical applications are minibuses and mini-trucks. The system is produced locally in China. Depending on engine size, various different components are used to configure the system. For 2- and 3-cylinder engines, the high-pressure pump CB08-16-1 is combined with an electric pre-supply pump in the tank. In 4-cylinder engines, the job of generating high pressure is done by the CB18-16-2 or CP1H-16-3, both with integrated pre-supply pump. All pump types are equipped with a metering unit for fuel delivery control, making them more efficient than pressure-regulated systems. The high-pressure pump compresses the fuel to a pressure level of up to 1,600 bar and delivers it to the high-pressure rail HFR-16. The deployment of a metering unit creates a fuel delivery controlled system, which is operated as a single actuator system. The high-pressure rail supplies fuel to the solenoid valve injectors CRI-116. The opening and closing of the nozzle needle in the injector determines the start of the injection and regulates the following injection process, as well as the amount of fuel injected. The solenoid valve enables 3 individual injections per cycle to be achieved, reducing emissions and delivering consumer benefits. This injector type, a further development of the proven CRI-216 model, was designed especially for use in the LPV segment and to conform to future China 4 emissions regulations. These injectors are also suitable for use with suboptimal fuel. The electronic control unit EDC-17 contributes to the precision of the injection, regulating the high-pressure pump and the injectors. It also supports the operation of a lambda sensor. The EDC can be deployed in 12 and 24-volt applications and can be installed in the chassis in close proximity to the engine. The EDC-17 enables adherence to current emission standards as well as China 4, while improving engine performance at the same time. The modular system enables developers to adapt its configuration to the demands of the engine at the lowest cost possible, while also ensuring compliance with China's future emission standards.
Bosch, invented for life.
In all markets worldwide, consumers demand three things in particular from new passenger cars: low fuel consumption, as little pollutant emissions as possible, while still offering high-performance drive power. Common rail systems from Bosch help to fulfill these requirements. The Common Rail System CRS220 is used in passenger cars with 3 to 8-cylinder diesel engines. It is an evolutionary further development of the proven CRS2 systems. It is a quick start capable system that can be combined with fuel-saving start-stop systems. Increased pressure levels of up to 2000 bar support the realization of downsizing concepts. Its modular construction makes the system adaptable to a wide range of engine types with a broad performance spectrum. The high-pressure pump CP4 compresses the fuel and delivers it under pressures of up to 2000 bar to the high-pressure rail. The pump is equipped with a metering unit for fuel delivery control. The high-pressure rail HFR20 serves as a high-pressure storage unit. Injection pressure is controlled with the help of the metering unit and a pressure regulator valve operated as a double actuator system. The injectors CRI220 are a key component of the system. They feature quick-switching pressure-regulating solenoid valves. High injection pressure, short intervals between injections, and integrated high-pressure volumes in the injector give engine producers great flexibility when it comes to designing the base engine. The results are benefits such as the economy and diversity delivered by a modular system construction, reduced emissions and combustion noise, reduced pressure pulsation, and an optimized injection process, higher efficiency and CO2 optimization via reduced return flow. Thus, the efficiency of the base engine and exhaust gas treatment can be improved still further. The injectors are also suitable for use with suboptimal fuel quality and thus for markets worldwide. The electronic control unit EDC17 also contributes to the high precision of the injection, controlling the high-pressure pump and the injectors. With solutions for all fuel qualities, the CRS2 series can be used in all markets worldwide. The progressive characteristics of the series for Euro 6 compatible engines make it another impressive contribution from Bosch for economical, cleaner running and powerful diesel passenger cars.
Bosch, invented for life.
In all markets worldwide, four characteristics in particular are in strong demand when it comes to passenger cars: lowest possible fuel consumption and pollutant emissions, an engine that runs quietly yet offers high-performance drive power. Common rail systems from Bosch help to fulfill these requirements. The Common Rail System CRS320 is deployed in passenger cars and light utility vehicles of the highest performance class. The system, equipped with piezo injectors, enables extremely quiet-running engines with the desired performance profile to be built. High injection pressures of up to 2000 bar make it possible to realize downsizing concepts, among other things. This enables the engine to deliver the same performance with less cubic capacity. That helps to lower fuel consumption and CO2 output without compromising on sportiness. The combination of common rail system and fuel-saving start-stop system is another option. The fully modular design of the CRS-3 systems make them adaptable to a broad range of engine types and a wide-ranging performance spectrum. The high-pressure pump CP4 delivers the fuel to the high-pressure rail, where it's kept ready for the injection at an injection pressure of up to 2,000 bar. With its high level of hydraulic efficiency, the CP4 achieves a delivery rate that fulfills all requirements up to and including light-duty applications. The high-pressure rail HFR20 serves as a high-pressure storage unit and is equipped with a throttle, a pressure regulator valve, and a rail pressure sensor. The system is operated as a double actuator system. The high-pressure pump supplies fuel to the piezo injector's CRI 320. The opening and closing of the nozzle needle in the injector determines the start of the injection and regulates the following injection process, as well as the amount of fuel injected. The piezo injectors operate so quickly that they accomplish up to 8 injections per cycle and also achieve very small pre-injection amounts. The reduced loss of hydraulic performance means that the fuel does not heat up as much, so that no additional fuel cooling is required. The piezo injectors maintain a consistent performance level with reduced flow through the hydraulic nozzle. That contributes to emissions reduction as well as reducing combustion noise. Piezo actuators develop around 10 times the power of solenoid valves, making the injector less sensitive to fuel impurities. The CRS-3 is thus highly robust and also suitable for use with fuel of inferior quality. The piezo actuator is integrated into the injector casing, making the injector slimmer and lighter in weight. They thus require less space for installation than solenoid valves. The electronic control unit EDC-17 regulates the high-pressure pump and injector function, thus contributing to the high precision of the injection. With the help of the control unit, current and future emission standards such as Euro 6 and Tier 2 Bin 5 can be adhered to. Future system generations with even higher injection pressures will enable an even more substantial reduction in fuel consumption and emissions. The Common Rail System CRS 320 is a further contribution from Bosch to more economical, cleaner running, and powerful diesel passenger vehicles.